Okay, so yesterday we saw how to work with um, inheritance, right? How inheritance is used um, in Python, right? And what we saw was that you can have base class and derived class. You can have base. So when you have that kind of relationship, okay, so derived class will always have access to the base class, correct? So all the members of base class will be available to the derived class. Now we also saw that if you do not want derived class, if you want, if the derived class has that member and base class also has the member, then of course derived class, the nearest, the derived class will be able to call the member. Okay, the base class member will not be called. Correct. So that's what we saw. Now let's say if parent class doesn't want to give access to the member. So that, okay, leads us to the next topic, which is called encapsulation. Okay. So encapsulation is called hiding the information. So we'll take yesterday's example itself. Okay. So you have here arithop, and arithop is derived class from D2 and mathop, right? And let's say, okay, it has class output 1, and this has class output. Okay, so you have class output here and you have class output here. Both the super op and math op and B2, all of them have class output. Okay. Now, if you try to access it, of course, you can access, right? Output from B2 is called because we are calling B2 first here, right? So both math hop and B2 has it. So since B2 is called first, B2 is nearest, and B2 member is called. Okay. So that, okay, you know, that is the, the way inheritance work, right? So now we're talking about encapsulation, and it's called data hiding. Let's say the parent or the base class doesn't want derived class to have access to. So information hiding here is done in 3 different ways, or not information hiding, the access to information is done in 3 different ways. So, so I'm going to talk about those types. You have here, it's called public. Then you have private here. Okay, so you have public and private, and you have second member, which is called protected. Okay, so there are 3 ways, or there are 3 types of members. Okay, see, we have seen 4 types of members that can be in a class, and each of these can be of 3 types, okay, based on the accessibility. Okay, so we say 3 types of accessibility provided are, okay, public. Now, what we have seen so far are all public. Public means anyone can call anything. Okay, so I can create another class. I'll call this as, say, test class. Okay, and in test class, I have a function called test method. Okay, and what I'm doing here, I'm calling, okay, I'm calling superop class output. I'm calling here, okay, say S1 equal to superop okay, and super1 dot class output. Okay, so see, this class is not derived from any of the above class. This is a separate class. Even this, okay, now if I call here, okay, let me delete all this, okay. So I'm saying T1 equal to test class, okay, and I'm not providing anything to it, okay, there is no need to do it. Now I'm saying T1 dot test method. So test method, okay, belongs to, okay, see, B2 is initialized, is coming from where? Class output, right? So if you say class output, see, B2 is initialized, is coming from init, because we are initializing super op inside the test class, and class output from sub op is also printed. Okay, so what we have seen here, this test class is no way connected to any of the classes above, right? But still it can call your super op. Super op class. Test class is no way connected to any of the classes above, but still it is able to call super op class members, right? This is called public. Okay, so now it's like you have a house and you construct a swimming pool in outside your house and you put public sign. Anybody can go. Okay, there is no need for anyone to make any payment. No need to do anything. They just go and can use your swimming pool because you have called it as public. So public members can be called by anyone. So public members can be called by any class member or object, by any class, right? So public. So what we have done so far, all the methods and the variables that we have declared are all public. Okay, we don't have to mention anywhere private or protected. Okay, it is all mentioned here. Now comes protected and private. Okay, so if you want to make a member protected, if you want to make any member protected, you need to add underscore, single underscore before the name. For private, if you want to make any member private, member private, you need to add double underscore. Okay. Now, what is the significance of this? Protected members can be called by derived classes only. But this is strictly not implemented in Python so far. Okay, so it says derived class can only be called by, sorry, protected members can only be called by derived class. Protected members can only be called by derived class, but it is not strictly implemented. That means if I go here, okay, and in the super app, and let me add one more class here, one more member here. In this class, let me add one more method here. So I'm saying class output 2. Okay. And to make it protected, I will add one underscore. So if you add one underscore, it becomes protected, right? Protected. Okay, class output 2. Now when I am calling in arith op, okay, so let's call arith op, a1 equal to arith op. Okay, arith op, I need to pass some values, right? Is it 2 values? Arith op needs 2 values, I guess, right? Or I can make this as equal to 0, equal to 0, okay? That way I don't need to pass any value, okay? So I added arith op. Now arith op, okay, is derived from math hop, and math hop is derived from super hop, right? So I can use dot, okay, underscore, okay. Now you see this, okay, this is the problem. It is, okay, so this is not derived class, isn't it? A1 is not derived class. A1 is not derived class. Okay, that's why it's not shown here. Now, if I go and which is the derived class of this? Super hop, right? Math hop. So I'm going to say M1 equal to math hop, and math hop needs one member, right? Right. So let me. Yeah. Now, if I say M1 dot underscore, what was that?
Class output 2.
Class output, right?
2.
Okay. So class output 2 is being shown here, right? Okay. So this is possible. I can even say T1 dot class output. Okay. So see here. Test class has no attribute class output 2. Right? T1 has no, because it is not derived from, it is not derived from, T1 is not derived from superop, but M maths is derived from there. So this is possible, but this is not possible. Right? Okay. Now if I add one more here. Okay. And I'll say private. And to make it private, you have to use double underscore. Correct? Now if you go and call double underscore. Okay. Now when you, oh, these are function, right? You see, double underscore is not called because single underscore is allowed, but double underscore is not allowed. Why? Because this is private. Okay. You can't call since it's private. Okay. Okay. You can't call because see, we could call the other one, but not this one, isn't it? So you can call the class output. Why it's saying cannot? Okay, my mistake here. You see this? Okay, class output is not member of this, right? Okay, so what I should do is I should go to test method, right? In test method, I'm calling, isn't it? Not here, sorry. I'm calling in test method, right? I made a mistake here. I'm calling it. So this is object is created in test method, right? Superop is getting called here. Now here, okay, I'm able to call class method, but okay, not but. I'll be able to call this also. I'll go and put some text here to distinguish between private output from superop protected, okay, from private. Okay, now when you run it, okay, so see, do you mean class output? Oh, 2 is there, right? Two here. Okay, so protected is called, right? Now, if I go and say S1 dot single underscore, okay, single underscore class is not shown, right? Is not shown. But when you call it, it executes. There is no error here. So this is what it means, that can only be called by derived classes, nobody else, but it is not implemented in, it's not strictly implemented in Python. Okay. So, okay, so protected members is being called, but technically it shouldn't be possible to call. Okay, so this is not yet implemented in Python. Okay, so see, so protected members should not be accessed by any other class outside the line. Okay, so it's like protected means only your friends can use it. Okay, so it's like you give passes to your friends. Okay, so if you have a swimming pool and if you make it public, anybody can go and use it. But if you say protected, that means those who have got passes can only do it. But that's the concept wise it's there. Concept is there, but it's not implemented. Still, anybody can use it. So that's why when you say S1 dot, you are not able to see class output. You are not able to see class output. But still, when you call it, there is no error. Okay. But if I go here, okay, so now we are adding, I think we got the name wrong earlier, right? So now we'll say class output to private. Okay, now if I try to do this, did I put private here? Private, yes. So now if I go to test class, okay, and if I say S1 dot double class output, this will give you error because it's private and it cannot be accessed. Okay. So above above method of superop is not accessible. Private members can only be accessed by the same class member. Okay. Private members can be accessed only by the members of the same class. Okay, can only be accessed by members of the same class. So if you are not the member of the class, and if you're trying to access private, you cannot. Protected members are available to the classes which are derived class, and they should be able to access. But technically it should not be callable or usable by any other class, but it is not yet implemented strictly in Python, so it behaves like public. Private members should not, but still it behaves like public. Okay, it says, it's just a recommendation by Python, but not actually strictly implemented. Did you get it? So this is how you can hide the information. Okay, you can make sure that particular class will have access or not have access. Now here I know the code. I have seen, we have access to the code. So we went and we saw, okay, this is private. Okay, but what happens? Let me call it, doesn't matter. But if there are some private protected, I'm sorry, okay. So private anyway you don't have access. Let's say if there's some protected member in list class or in string class, still you can't use them because we don't have the code to see which are the members which are protected. But when you see str dot, just like we did, test class dot, we will not be able to see private members or the protected members. Make sense? So this is how you can save the information. You can make sure that classes or the methods or the variables are not accessible outside the given class. Okay, so this is called your encapsulation. All right. So with that, we end our discussion on class and objects. Any questions? Okay. So now we'll move on to next topic. Okay. For what I want to do is I want to I want to talk about how to access different file format. Okay. So how to read text file or Excel file or JSON file. And this will be very helpful for your work. Okay. This is going to be very helpful for your work. And once we do that, then we will do how to work with database. Okay, so database also will cover, or in fact we'll do a couple of other topics, then we'll go to database. Database should be the last topic. So I'm hoping that by today and tomorrow we'll complete handling files, and then we'll go to error handling, and few other topics we'll do. Okay, so now we will begin with next topic, which is handling external files. Okay, handling external files. Okay, so that means you have data in text file, let's say, okay, or in JSON file, or let's say .csv file. Okay, all file form, even zip file format is accessible by Python. Python can read your zip file as well. Okay, so we will do some of the common files like CSV, JSON, text. We have, in the book which I've given you, you can even see that you can access HTML file or XML file also you can access. Okay, so let's talk about these important file formats. So mostly the data that you will get from other sources, networking data and things like that, you will be mostly getting in. Earlier it was CSV, but now mostly JSON file format is used. Okay, so you'll be getting it in the JSON file format. But before we get into that, let's see how we can handle file reading and things like that. Okay, so this is now, some of this code will be different for Windows and Mac. So this portion is we are going to talk about OS, operating system. Okay, so we will import OS module. So what is module? Module is collection of files, isn't it? So we'll import OS module, and some of the things that we're going to do, okay, I just said, is very specific to, because file, when you're reading a file, correct, it could be you could be using on a Mac machine or the Linux machine or a Unix machine or a Windows machine, isn't it? So the command that you will pass, for example, if I have to list the files in the directory, right? Now, command that you will pass for listing is like ls in Unix and Mac and other things, right? But it is dir um, in Windows, right? So Python code will be same, but how will you know what to pass? Should I pass ls or should I pass dir? Right? So you can decide based on the operating system. So you can write a single program for which can work on both Unix and Windows, and you can decide which command to pass. Okay. So for example, I'm going to show you one example here. Import OS, right? So if OS has functions related to the methods or the functions which you need to use to handle OS related commands. Okay, so you want to see the OS name. Okay, so print operating system in use. Okay, you can say OS dot name. Okay, so OS dot name will tell you the operating system name. So generally, Windows operating system is based on NT. Okay, the platform on which Windows system now I'm using. I think Windows 9. Okay, Windows 9 is based on NT platform. Okay, so when it is Windows, you will get NT platform, NT platform for Windows machine. Now you have POSIX. POSIX is the platform for your Mac and Unix and Linux machine. Okay, so POSIX platform is for Mac, Unix, and Linux machine. You might have Java machine. Okay, the Java is for Java machine like JVM. Okay, so these are different platforms. So you can check which platform you have, and then you can pass a Java related command or Unix related command or NT related command. Okay, etc. These are different types of OS. So what I can do is, I can say if OS equal to name, if OS dot name equal to NT, then you will say Windows related commands, correct? So you can say here print, you are working with Windows machines, right? A machine rather. You can say elif OS dot name equal to POSIX. You will say print you are Mac and Unix and Linux, they have same platform. You are working on Unix / Linux / Mac machine. Okay, so you give those related commands you use. So same program, okay, you can say print some other platform, please check whatever, right? I can use Java, whatever. Right now, since I'm using on Windows, I'll try to add few stuff there. But if you have access to other machine, you can try this code there. Okay, I'm sure, like in your environment, you'll be using more of Linux machine, right? Generally in networking kind of scenarios. So yeah. So now let's say I want to clear this. Okay, I want to write some text. Print some text. Some text slash n, some text slash n, some text. Okay, so when you run it, it will always give you some text, isn't it? Now I want to clear the screen. So what is the command to clear the screen? In Windows you have, so what I'll do, if it is Windows machine, to clear the screen, we use CLS. Okay, so here you pass OS dot system, and you say CLS. OLS dot system CLS. Okay, so it is not a this thing. It is not your command prompt, right? That's why it is showing clear the screen. Okay, if I had done same program on command prompt, okay, let me show you here. So I'm going to use CMD command prompt, and okay, so I'm saying Python. Okay, now here let me add few things like dir. Okay, now I'm going to say Python. Okay, Python, and I need to get the path here. Wait, P11 is the program, right? See, this is the path, right? Or I can copy the entire Python path here. I copy it and I go back to here and I hit enter. So see, entire thing has been cleared, right? dir, and then you run it, CLS is run, and you can get entire screen is cleared. Okay, so this is how you can throw a Windows related command. Okay, now in this case we don't have to write this junk, right? Let me remove it. Now similarly, if it is your Unix, you will say os.system, and you have clear. Clear is the command to clear the screen. Okay, so this is how you'll be able to clear the screen, right? So see, there's nothing wrong with Python. It's only your the OS uses different command, right? So you can choose, you can check, and then you choose your specific commands to run on them. Make sense? Okay. Now let's say you want to create a directory. Now this P18 is at this location. This location, Python project. Okay, Python project is where P18 is there. Now you want to create, let's say I'll create a test. I'll delete this test. Okay, so gone, right? Test is gone. I'll create a make directory here. Okay, MK directory. So create directory. The command to create directory is MK directory, isn't it? So how do I run it? Okay, I will say os dot mkdir, and then you give, I'll give test1 here. Okay, and I will run it. You see, test1 folder is created. Okay, so you're able to clear the screen. All right. So this is how you can use command. You can read the directory, you can read the files, you can read the file name, okay, by running Windows command, or what you call the DOS command, right? It used to be DOS command. So you can use DOS commands to read the file name, things like that. Okay, so now let's see how to, I will go to this one. I am going to show you how to read files here. Now, we created a test1 folder, right? Obviously, there's nothing in test1, right? We just created, so it's empty. Let's create a content here. Okay. So I'm just thinking which file to create. Okay. I'm going to write a poem, let's say. Okay. So I told you, right? If you have to write multi-line, it is triple quotation, right? So let's say I'll write twinkle, twinkle. Okay, so when you are writing multi-line text, you can put it in triple quote, right? Either single triple quote or double triple quote. And now if I have to print poem, okay, and you run it. So you see, you're getting this line. Now I want to save this in a text file. So remember, okay, so far, all our programs have been within the Python environment. That the way you will work in your home is different than the way you will work outside, isn't it? Because if you have to go outside your area, you need to know where to go, how to connect, right? You cannot simply treat your shopping mall like your home, isn't it? So far we were at home, okay? We did everything. We did print, input, whatever we did, it was all within our zone. Now we are going beyond our zone. So to go beyond our zone, we need to have some kind of bridge, some kind of connection, some kind of connectivity, right? We need to have some kind of connectivity, okay? So how do we do this kind of connectivity? So first we need to tell what we want to do, okay? Now, if you talk about files, okay, there are different modes of file, okay? Modes of file. So you have R for read, W for write, okay, A for append. Okay, so when you are reading a file, you need to read the file in read, write, append mode. When you access the file in read mode, that means you're only going to perform read operation on that. You're not going to write anything to it. You're only going to perform read operation. When you say W mode, you're allowed to write only. You cannot read it. You're only allowed to write. Okay, and when you say write, all the previous content, okay, all the previous content will be deleted. Okay, because when you say write, you're writing to it. So all the previous content is deleted. Okay. Okay. So read, you can only read, you can't write. Okay. Write, you can only write, you can't read. But previous content, all the previous content is deleted. Okay. If you want to perform both read and not read. Okay. Sorry. If you want to write to the existing content, so writing whatever information is there, you want to save it and you want to write on top of it. Then we use append. Okay. So in append, it's like writing additional content to the existing file. So it is previous content plus write. Okay. If you want to open in read and write mode, you will say R plus. R plus is read and write mode. W plus is write and read mode. Now, can you tell me what could be the difference between R plus and W plus? Both look same, right? Read and write, write and read. Are they really same? Okay. So see, they are same, but with a minor difference. If I tell you read and write, so now you need something to read, right? I mean, not write in the sense W write, R write. You need something to read. If I tell you read and write, but I don't give you anything, any book, you will say, what should I read? That means to read and write, the file should be existing. That's the only difference. Okay. So when you say read and write, you are opening a file in read mode. The file should be there. Correct? File should be existing. But when I say write and read, say, okay, let me write and I will read whatever I'm writing. So file need not be there. Okay. And append mode, again, it's like append and read. Basically, append is writing only, right? Append and read. So same thing, okay? If you are opening in W plus, W or W plus, A or A plus, okay, file need not be there, need not be there. But if you're doing in R mode, R or R plus mode, file has to be there. File has to be there. Okay. So I have a simple content here poem and let me write to it. To write, file need not be there, right? I can create a new file and write to it. But if I have to open this in read mode, then file has to be there. So if there is no file, I can't read no file in read mode. Okay. So that's why let's first do write. Now in write, you can do write where you're writing all the content. You can say write line. You're adding line by line. Or you can say write lines, multiple lines. Now, difference between write and write lines, write is also multiple line, right? It can write multiple line. Write lines can also write multiple lines. But here, the content has to be in list. Okay, so let's see this. So I have a simple text, so I can only use write, isn't it? So first I need something called as file pointer. Okay, you need file pointer. That means you need a variable. It's an object. So you need an object. See, everything is object. Now you know that. You need an object which will point to where you want to put the content. Okay, obviously we are using Python to access a text file. Right now we're talking about text file. So you need a pointer which will take you to that text file, which will take you to that text file. So if I write a file pointer here called file PTR, you can write, this is any object, right? So this is called creating step 1. Okay, I'll put step 1. Create a file pointer. Okay, create a file pointer. So I'm saying file pointer. What does it need? It needs two things. Okay, where do you want to connect? Needs where and how. That means which file you want to connect and how do you want to connect? Mode. How means mode, right? Where means which file and how means mode. So I'm going to say file pointer equal to open. Open means I'm opening a file. See here, file and mode. Okay, so these are two things. So I'm going to open. See now, you have this absolute path and what is the second thing? Relative path. What is absolute path? Absolute path means you need to give drive also. Okay. Absolute path means you need to provide path with drive also, like a:/ something like this. And when you are saying relative path is with respect to where you are currently. Relative path is with respect to where you are currently. Absolute path means, okay, with drive, like a:/ c:/ d:/. You need to give, so you're giving complete path, full path. So in this case, I will use relative path, okay? So I am at this location. I'm at, if you point your cursor, it'll show you, or you can even see here, okay? So C users, HP, PyCharm projects, Python project. This is my current folder. So if I'm using relative path, it is with relative to this location, So with the related to this location, I want to get into test1. So I will say test1. Okay, now you can use this slash we use in Unix format, right? Or Mac or Linux or Unix format. You can give this format, or if you're giving this format, then generally we have to give 2. Remember, this is your escape sequence character, right? The escape sequence. So if you give 1 and if you give n or things like that, it can give a new line, /n/t has a meaning. So if you want to avoid that kind of problems, mistake, you give double slash, because they'll cancel out, right? It'll come as single slash, or better you give this format. So I'm saying open test1. This is the folder /abc.txt. So I'm going to connect to abc.txt and in read mode. Okay, by default it is read. If you don't give, it is read. Okay, so I want to give in read mode. Okay, now when you open a file, better you close it as well. Okay, it's always a good practice to close it. So I'm closing the file. Okay, now see, this folder exists, but file doesn't exist. So I'm trying to read a file which is not there. No such file or directory exists. I'm reading a file which is not there, correct? So you cannot use R or R plus when file is not there. If file is there, then you can use R plus W. Then in that, if file is there, then R plus and W plus has no difference, okay? It means the same. So I'm going to say here W. Even if I use R plus, okay, it will give error. So I'll give only W. W means I want to write. Now, when you want to write, it doesn't matter whether file is there or not, because whatever content you will write, okay, we'll get into it. So now you see, if you expand, see, abc.txt has been created. Okay, so we just created this file. We have not added, we have not written to it. We have just opened test1.abc.txt in write mode. So if file exists, it will be there. Okay, if I run it now also, no error, because the file is there. So that's okay. You can write to existing file also. Now we will write to it. So how do we write to it? We have 3 ways to write, right? So we have write method, and write line, write lines. Okay, so we will start with something called as write. So file pointer dot write. Okay, and I'm going to add the content, that is poem. Okay, now you run it. Okay, now you go and open abc.txt. See, the content has been added. Exact the content that we gave there. Now you run it 3 times. 1, 2, 3, 4, 5, 6. I ran it 6 times. You go and see only 1 time, because every time it is adding, it is deleting the previous content and adding a new content. It is deleting the previous content and adding a new content, isn't it? Now, instead of W, if I put A and then I run it 1 time. So see, already content was there. So when you run it A again, okay, so what will happen? Second time the content got added. See, this is your first content, and from here the second content got added. Already content was there, and we said open in A mode. Open in A mode means previous content is saved. Now you go and add again, and again, and again. Now you go here and you see the content is getting added. Make sense? So this is called append mode. Okay, so we have seen W mode, we have seen A mode, we have seen write. Now what I'll do is we will read the file and we'll stop here today. Tomorrow I'll show you how to perform read line, read lines, write line, write lines. Okay. So now this file is created, content written, done. Now I need to read the content of this, right? So to read it, I can do it here itself. Okay, I can write, I can say read, or let's say I close it. Okay, and then, I open it again. You can do it together, okay? And here now I'm saying, now if I try to read here, now if I see now, if you are saying write, that means you have to pass something to write, isn't it? I can't say write nothing. I have to say what you have to write. So I'm saying poem should be written. When you are reading, then you don't have to pass anything, right? Read is simple read and you don't pass anything. But when it reads, you have to save it in a variable, isn't it? I need to save whatever is being read into a variable so that I can use it for my purpose. So I'm going to say read content or whatever right here. Okay, so now you close it and you can print I can say content read from the file. Okay, /n, so the content gets written in the next line, and I'll say read content, and I run it. Oops, line number 26. Yeah, this is what I wanted to show you, isn't it? See, when you open in A mode, it says file not readable, right? Unsupported operation. A and W, you cannot read it because file is in write and append mode. To read it, you have to open in read mode, isn't it? Only when you open in read mode, you'll be able to read the content. Now see, this is the entire content from your file. It is being read here. All right. Make sense? So you can write to a file, you can read to a file. So here you need to follow first path, which is to create a pointer to tell, you have to give all the information. I want to open a file, which file? Okay, file at this location and this name, fine. In what mode you want to open? In read mode, great. Then you will be able to open that given file in read mode if you have access, obviously, right? If file exists, you will be able to read it. So this is how we can read and write a file. We'll stop here today. Tomorrow we will see few more methods, right? We will see how to perform read lines or read line. Make sense?